Hello, good day everyone. Welcome to another math series. I am Dominic Manuel. I am your instructor for today's discussion. So, our topic for today is all about the different types of integration, specifically in work, integration using other substitution technique, integration of trigonometric function, integration of definite integral, and last, the volume of solid by slicing disc, washer, and cylindrical shell. So first, we will tackle about work. Okay, so let's have the work. So here's the problem. A circular swimming pool has a diameter of 24 feet. The sides are 5 feet high and the depth of the water is 4 feet. How much work is required to pump all of the water over the side? So, use the fact that water weighs 62.5 pound per cubic feet. So, first things first, we need to list or note all the given values that the problem has give. So, given 24 feet pool diameter. So first, in 24 feet is equals to the diameter. And then, we need to find the radius of the pool. So therefore, what is the formula of the radius? So the formula of radius is equal to diameter over 2. So therefore, r is equals to 24 over 2. So r is equals to 12. So our radius is 12. And then take note, 4 feet is equals to water depth. 5 feet is equals to the side height. And last, the 62.5 pound cubic feet is the water weight density. So what we are going to do here is consider a thin horizontal slice of water at depth times the measured from the bottom of the pool. So we need to take the dx as the thickness of the slice, and then the area of the circular cross section. So the area of the slice. So what is the formula of area? So area is equals to pi r squared. So isolve natin. Area is equals to pi. What is our radius? Radius is 12. So 12 substitute squared. 12 squared is equals to 144. So therefore, we have 144 pi feet squared. So now, we need to find the mass of slice. So mass of slice is equals to, mass of slice is equals to weight equals volume and weight density. So our volume is equals to 144 pi dx times 62.5. So, we have the answer of 9,000 pi dx pound. So that each slice is a depth x from bottom, so it must be lifted a distance of 5 minus x feet to exit the pool. So the lifted distance must be 5 minus x. So the work to lift the slice is dw is equals to weight and the lifting distance. So what is our weight? Our weight is 9,000 pi. 9,000 pi, and then the lifting distance is 5 minus x dx. Don't forget the dx. So compute. So now, to find the total work, integrate from 0 to 4. Since why 0 to 4? Because since the water extends from depth 0 to 4 feet. Gets? So our formula here, or our constructed equation here, is the integral of 9,000 pi 5 minus x dx. Sorry. So work is equals to integral of sorry. So take the constant out of the integral, like this is equals to 9,000 pi integral of 405 minus x dx. So let's integrate first the 5 and the negative x. So equals to integral of 5 minus the integral of x dx. So it is equals to 9,000 pi 5x minus x squared over 2 0. So let's compute it. 9,000 pi equals to 5. Substitute the value of x to 4 minus, substitute 4 squared 2 minus 5, substitute 0 minus 0 squared over 2. So calculate. Will become 5 times 4 equals to 20 minus 4 squared 16. 16 over 2 is equals to 8. Good. No. Minus 5 times 0 equals to 0. 0 squared is equals to 0. So 0 over 2 equals to 0. So copy the 9,000 again. So 20 minus 8 equals to 16. Sorry. 12. So 12. 0 minus 0 equals to 0. So we need to multiply the 9,000 pi in the 12. So 9,000 pi times 12 is equals to 10,800 pi feet per pound. So this is our final answer. So the total work that is required to pump all the water out is 10,800 pi feet per pound. Okay, now let's proceed to the integration of other substitution techniques. So there are different types of substitution techniques, the miscellaneous and the Weierstrass substitution. So the miscellaneous involves polynomials, and the Weierstrass substitution involves trigonometric. So we have an example here of integral dx over 5 sine x plus 2 cosine x plus 2. So now, since we have encountered trigonometric functions, so therefore we need to use Weierstrass substitution. So the Weierstrass substitution has t equals to tangent x over 2. Why? Because in Weierstrass substitution, we use here half angle substitution so that we can let t to be equal of tangent x over 2. So here in Weierstrass substitution, we have trigonometric identities. For the sine x is equals to 2t over 1 plus t squared. The cosine x is equals to 1 minus t squared over 1 plus t squared. The tangent x is equals to 2t over 1 minus t squared. Cotangent 1 minus t squared over 2t. Second x is 1 plus t squared over 1 minus t squared. Cosecant x is equals to 1 plus t squared over 2t. So here in our problem, since it is just sine x and cosine x, so we can write that sine x is equals to what? That 2t over 1 plus t squared. 2t over 1 plus t squared. Now, our cosine x is equals to what? So our cosine x is equals to 1 minus t squared over 1 plus t squared. So now, my question, how can we find our dx? So to find our dx, we let our tangent to be arc tangent. So therefore, we'll have arc tangent t is equals to x over 2. To get rid of that, so we'll divide it, multiply it by 2. So cancel 2 and cancel x and cancel the 2 and x over 2, so it will become 2 arctangent t is equals to x. So get get their both derivative, so it will become 2 dt over 1 plus t squared is equals to dx. So our dx is equals to 2 dt over 1 plus t squared. So we have now our dt. So our dt is equals to 2 dt over 1 plus t squared. Okay. So now our substitutions are already complete. Now we let our equation to be substituted. So dx is equals to 2 dt over 1 plus t squared over 5 times sin x is equals to 2t over 1 plus t squared plus 2 times, what is our cosine? Our cosine is 1 minus t squared over 1 plus t squared plus 2. So now, to get rid of that fraction, we need to multiply it by 1 plus t squared over 1 plus t squared. So now, our derivative, sorry. Our integral will become 2 dt over 10t plus 2 times 1 minus t squared plus 2 times 1 plus t squared. So take the constant out of the integral. So 2 integral of dt over 10t. So distribute. 2 times 1 equals positive 2. 2 times negative t squared equals to negative t squared plus 2 times 1 equals to 2. And then 2 times positive t squared equals positive 2t squared. So cancel the unlike terms. The negative 2t squared will be cancelled. So the new equation will become 2 integral of dt over 10t plus 4. So thus the 10t plus 4 is factorable. Yes, it is. So the equation will become 2 integral of dt over 2 times 5t plus 2. So cancel out the 2. So the equation will become integral of dt over 5t plus 2. So now we let u equals to 5t plus 2. So our du is equals to 5 dt over 5 to get rid. So du over 5 is equals to dt. So let's have another page. So our integral now is du over 5 over u. So we change it because we let u become 5t plus 2. So that's the u. and the dt is du over 5. So take out the constant of the integral, so it will become 1 over 5 integral of du over u. So now the identity of du over u is equals to ln absolute value of u plus c. So now it will become 1 over 5 times ln plus c. So now this equation is equals to 1 over 5 ln, what is our u? 5t plus 2 plus c. So now, do you remember that our t has a value? What is the value of our t? The value of t is equals to tangent x over 2. So you need to substitute it. So the final answer will become 1 over 5 ln absolute value of 5 tangent x over 2 plus 2 plus c. This is the final answer. So now let's proceed to the volume of solid by slicing disc, washer, and cylindrical shell. So our problem is find the volume of the described solid as a right circular cone with height and base radius. The radius of each disc at height x is given by y of x is equals to r over h x. So now this problem is identified as disc. Why? Because it is given in the problem, and to explain it, this problem is a cross section circles. So it means that at any height x, the cross section is perpendicular to the height is a circle with radius y of x equals to r over h x. So in this problem also, there is no hollow region. That's why this problem is disc method. So the formula of disc method is equals to volume is equals to integral of height pi r h x squared dx, where a of x is equals to pi r h x squared. So let's solve it. So volume is equals to take the constant out, take the pi out of the integral. So pi integral of h r squared, distribute the squared, and h squared x squared dx. So volume is equals to pi r squared h squared integral of h and x squared dx. So integrate x squared, it will become volume is equals to copy pi r squared over h squared. The integral of x squared is equals to x cubed over 3. And the boundaries. So now you just copy again the pi r squared over h squared times substitute substitute x to h and also 0. So h cube over 3, it will close, minus 0 cube over 3. So it will become volume is equal to pi r squared over h squared h cube over 3. So this volume will become volume is equals to pi r squared h over 3. So this is the final answer. So we have given a problem of integral of sine cube square root of x over square root of x dx. So now we let u equals to square root of x so that we can proceed. Square root of x. So x equals to u squared. So dx is equals to 2u du. So let's substitute u and dx. So the equation will become sine cube u over u 2u du. So this will become, take the constant out of the integral, so that this will become 2 integral of sine cube u du. To evaluate integral of sine cube du, we use the identity of, so sine cube u is equals, or we can reform sine cube u to sine u times sine squared u. So this will become sine u times the identity of sine squared u is equivalent to 1 minus cosine squared u. So 1 minus cosine squared u. So now we can have 2 integral of sine u times 1 minus cosine squared u du. So we let again, so the variable we will use is v. So let v equals to cosine u. So the derivative is equals to negative sine u. So substitute again, 2 integral of negative dv times 1 minus v squared. So why negative dv? Because our dv is sine u, and then negative dv times 1 minus b squared, because 1 minus cosine squared du, we let that as v, so that's why it is 1 minus v squared. So take the sign out of the integral, so the positive 2 becomes negative 2. integral of 1 minus v squared dv. So, negative 2, the integral of 1 minus the integral of v squared dv. So, it will become negative 2 times v minus 1/3 v cubed plus c. Now, substitute back the cosine u. So, this will become negative 2 cosine u minus cosine cube u over over 3 plus c. And then substitute back the u is equals to square root of x because our u is square root of x. That's right. So the final answer is cosine negative 2 cosine square root of x negative cosine cube square root of x over 3 plus c. Final answer. Okay, let's proceed to integration of definite integral. So, we have here integral of pi over 2 and the lower boundary is pi over 6 cosine theta ln times sine theta d theta. So, here, we let u equals to sine theta. So, our du is equals to cosine theta. So, now we can reform that as integral of sine pi over 2 sine pi over 6 ln u d. So let us compute first the sine pi over 2 and the sine pi over 6. So it is sine pi over 2 is equals to 1. Sine pi over 6 is equals to 1/2. So copy ln u du. ln u du. So now ln u du is equals to u ln u minus u. So equals to u ln minus u. I know, sorry, mali. Ln u minus u and the boundaries of 1 and 1/2. So equals to, substitute the values, the upper and the lower boundary. So we exchange u to 1 ln 1 minus 1 minus 1/2 ln 1/2 minus 1/2. So here we have 0 minus 1 minus 1/2 minus ln 2 negative 1/2 equals to, so 0 minus 1 equals negative 1, so minus negative 1/2, arrange ln 2 minus 1/2. So this will become negative 1 plus 1/2 ln 2 plus 1/2. We distribute the sign. So equals to negative 1/2 plus 1/2 ln 2. So we have the final answer of 1/2 ln 2 minus 1. That's it for today's discussion, all about the work, the integration of substitution by other techniques, integration of trigonometric functions, integration of indefinite integral, and the volume of slicing disc, shell, cylindrical shell, and washer. So, thank you for listening, and on to the next topic.